Hi, in this video we are going to build a relay timer first on the breadboard. All components, I'm going to explain the schematic, I'm going to show you the wiring diagram for the breadboard, and I'm going to demonstrate it on the breadboard with actual AC load. Then we are going to draw the schematic on a PCBX EDA, which is a service provider for printing this. We can, after drawing and selecting components, we can produce the PCB or design the PCB and then place order PCB like this, or you can do the full assembly with high quality components and produce it ready for use at very reasonable price and a reasonable timing. The operating voltage for the module is 6 to 18 volts, but it can operate with 5 volts. If you don't want to use external 18 volts, you can connect directly 5 volts either on breadboard or the actual circuit. Now when I press it, it can turn on the load and it will turn it off based on the value of the resistor and this variable resistor here. Or we can have it in reverse, so the load is on, press it, turn it off, and it will turn it on again. Many times we need to turn on a load using a timer with a predefined time. For example, 555, you just press and the load either is on and it goes to off, or it's off, it turns on. So we're going to build this timer circuit with 555 IC with 2 relays. Simultaneously I have 2 drivers, so we can turn them on and control the load. After that we are going to draw it and produce the PCB using PCBX Service, which produces amazing high quality PCBs on their EDA, on their website, so you don't need extra tool. You just do the you just draw first your schematic and then design your PCB, and you can place order either for the PCB or for actual PCB assembly. So this one, the circuit works with 5 volts because many times the system operates with higher voltage. Here the input voltage is up to 18 volts, and I've placed here a regulator so we can get 18 volts, and this will convert it to 5 volts, and the rest of the circuit works with 5 volts. We have a potentiometer here that we can set using this variable resistor. We can set the time from maybe less than 10 milliseconds up to 10 minutes or even higher. You can place your resistor, or we can use resistor in series or in parallel using this connection, so we can put resistors and achieve that. We have a start button and it will start and the relay will energize, and then with this you can cancel it if the time is long and you want to cancel it. For each switch we have here 2 extra pins that you can connect it to external switch or external voltage source or whatever you have. I used 2 relays in parallel. They are in parallel, they will be turned on together and they will be turned off together, and the pins are in here. So as you can see, the right pin, these 3 are, as you can see, these 3 pins are these 3 pins belong to that relay, and these 3 pins belong to here, to this relay. So the right pin is connected to the right pin of the second relay, the middle pin is connected to the middle of the second relay, and the last pin is connected from the back layer here to the last one. So they are in parallel. You can connect your load, and each relay can handle, based on this relay that we have, 10 ampere, so you can have 20 ampere in total to control a 20 ampere load. Connected, I've glued these 2 relays together, and I'm going to show you the wiring. So I've connected them, so this will act as one relay, and we will energize them with these 2 wires to control our load. The 555 circuit has been taken from this book, which is a free book from Colin Michel, from page 25. This is our circuit. We have a push button to start, and there is a 2.7 mega ohm resistor with 500 kilo ohm, and there is a capacitor, and when you push it, it will turn on this LED. Now, the time is calculated using R. These two are in series together with this C. So time is equal 1 times 1 times RT and CT, those two resistors and capacitors. If you multiply it, that's what you get in the time in seconds. And for the reset, I use here a wire from pin 5 to reset this. I'll provide you the link to the book if you want to download it. Here is the schematic of our project. At the heart of the project is the 555 relay. At the heart of the project is this 555 timer, and we are connecting it to 5 volts. If you have power supply that is not 5 volts, then you can connect your power supply here, for example up to 18 volts. It comes to this 7805. This will output 5 volts. This side is ground, so 5 volt comes and it will supply power to the. This is 10 kilo ohm resistor. This is one resistor that and here this is a potentiometer or variable resistor where we can set the time, and from this side we have a resistor coming that goes back to positive, to 5 volts. And I put these connectors, so between this line and this line we can put resistors. You see these two resistors, this is connected but not connected to each other. The other one is now not connected. So we can connect them in parallel by creating a jumper here. We have built it. You can use this kind of jumper or wire or whatever you want. Now 2 of them have been short-circuited. Now if I connect one there and one in here, it would be like this. These 2 will be connected and these 2. So these are now in parallel. We have so you can connect them like that and it will be in series. But if you want another fixed resistor externally, just connect it to this pin, which we have provided this connector here. Simple. Just connect your own resistor, whatever value you want, beside this potentiometer that you can select and change. This is a little intimidating. You think why it has a lot of pins. This is just a push button in the schematic design. It has 4 pins, but 2 of them are connected at the top, 2 at the bottom. Also we have connected external connector if you want to use external push button. So one is for the stop. The one that is connected to this capacitor is for the reset stop. One is for the start and then this is for the stop. The output is pin 3 connected to 330 ohm in series with an LED. When the output is on, this will turn on. And then we have relay driver, which I just explained, so you can connect it and drive this relay, and from the same pin we have one wire, another relay. These 2 relay will simultaneously turn on and off, and each has driver and they are connected. Let's say here's the wiring diagram that I used Fritzing to draw. This voltage, that this battery is not AA. This is 6 to 18 volts battery that we have connected. This portion is for voltage regulator that receives the up to 18 volts and outputs 5 volts. So these 2 wires are 5 volts. What I'm going to demonstrate is connecting 5 volts in here. But if you need to convert it, just use this 7805, which is a 5 volts regulator, and it will work. And here, this portion is the actual wiring on the breadboard. The top is negative, the blue line, and the red is 5 volts. And the same way, 5 volts red is connected to the red, and blue is connected to the blue. Here, this is our 555 timer, exactly that as I've shown in schematic. This is a potentiometer or variable resistor, 2 push buttons, and LED. And 3 is outputted up to here to control the relay, but I brought another wire, white wire here via this 330 ohm resistor to turn on this LED. These are 2N2222 or any NPN transistors that I mentioned. They will work. So 2N2222 is better. I've connected one diode, so you can connect it like this. Here's a schematic of driving a relay. To drive a relay, you need a transistor. This is called NPN transistor. You can use BC817, or you can use 2N2222. Emitter is connected to the ground. Base, this pin is base. Base is connected using 1 kilo resistor. This is our signal pin, and this is collector. Our relay has a power wires. One side is connected to 5 volts. The other side is connected to collector. Between one wire of relay and the other wire of the relay, you place a diode. This is 1N4001 or any diode that can handle about 500 milliampere. This side is cathode, the side that has the line, it will be connected to 5 volts, remember. And then we have 3 pins, normally open, normally closed, and then common. And here I put this multimeter in continuity tester. If I connect it, it will buzz. And this is the relay for the 3 pin. I'm going to connect one to the middle, which you must connect it. And one of these, if I connect it in here, it will not buzz. And if I connect it here, so this is normally closed. And this is normally open, meaning you will connect your one wire in here and one wire in here for the load. And when the relay is turned on, it will connect these 2 wires together like this, and your load will be turned on. This project, we're going to use this bare relay. This is a 5 volts relay, but you can use this type of module. It has 3 pins, 5 volts, ground, and signal. They have been mentioned here as N, VCC, and ground. So you bring the pin 3 from our circuit to this, or you can use this type. This is high level trigger, and this is low level trigger. It means when the signal goes down, this will turn on with 0 volts, and when it is above 2.5 volts, when it is high, this will turn off. But this one will turn on with high signal and will turn off with low signal. So I'm using this bare relay to drive it, and I've attached these 2 using this super glue. Just put 1 drop. Here is the actual circuit. These 2 wires are my positive and negative, and I've connected it exactly the way I've shown. Timer. I just put 1 push button because it did not fit here, so I was using a wire here. The job of push button was to connect it to the positive to turn it off, and here this wire. Other than that, everything is the same. And here is our relay. I've connected 2 relays, so to reduce the amount of wires. These are exactly the same that I've just shown. So the right wire of first one is connected to the right of the second one because they are parallel, and the left one is connected to the left. And this is our power for the relay. Then we are using the middle pin, the common. Common is connected to the other common, and here is a common wire. And I'm using the left wire, which is normally open. This is connected to the other one, and this is another wire. So when we turn this relay on, it just connects these two wires internally, and the circuit will be completed. Now for my relay, I'm just connecting one wire to the positive. So this red is my positive. And the other for the power is connected to the collector, or this side of diode. As you can see, this diode is connected via this wire in here. And that is the positive. And let's test it without any load. Turn on, and now it is energized and connected. If we have a load here, it will be turned on, and it's turned off. Amount of time, the time can be set using this potentiometer and this resistor. So we can or reduce it or increase it. Let's do it again. Wait for this to turn off. So let's reduce the time. I'm turning it clockwise. Hopefully that side is counterclockwise. I will rotate it until I hear clicks. Let's see somewhere at the middle. So it got shortened. Let's go more shorter. Yeah, now it clicks. So this is the smallest amount of time that we have with this resistor. Let me show you this resistor. I'm going to remove it, showing you the resistor value. It's 1.9, perhaps it's 2 kilo ohm. We can use smaller resistor to decrease the time. Now I'm connecting a wire instead of resistor from here to 5 volts. And now let's rotate it clockwise. There is some value. You see, as soon as I press it, it releases. Increasing it a little. Now 1 second, almost half a second. I increase it, but if you want to use a different value for the resistor, put another fixed resistor here and it will work fine. For this demonstration, I'm going to use this AC bulb. This is a plug that will be connected to wall outlet, and the light will be turned on. The middle, at this point, I have disconnected the wire, one of the wire, the live wire here, and I've twisted them and prepared them. These two will be connected to the relay. Job of relay is to turn it on by connecting these two wires, turning on the light, and disconnecting it, turning it off. So this can be a bulb or a fan or any other load. The same way the relay will connect it and disconnect it. The two wires of the bulb have been connected to these two wires of the relay. The relay is connected. The power is also connected. Let me press this. The load is on. And based on the time that we set, it will turn on and off. you can switch. Of course, you can switch the wires from normally open to normally closed. When you connect it, it will be on, and when you turn the relay on, it will turn it off. So the operation will be in reverse. This project that you are watching is produced using high quality products from PCBX. PCBX can produce your PCBs, or they can do full assembly PCB. At the moment, for each new user, they offer 10 PCBs for $1, or you can do full assembly of 10 PCBs for free. The process is very simple. You click on PCB code, upload your Gerber files, review your product, select the options in terms of quality of material, number of layers, thickness, and tons of other options, and place your order. You can draw your schematic by selecting the components, then design it the way you want it, preview it as a 3D model, once you are satisfied, you can click place order, either place order PCB or place order for PCBX of full assembly. If you select PCB, for example, you don't need to upload the Gerber file or anything. All the information that comes directly from the EDA, you will see all the layers of your Gerber file. You can also view it in 2D, and also you can preview the 3D of the PCB. Add it to the cart and place your order. If you wish to place order for high quality fully assembled project, click on order and order PCBA. The same as the PCB, you will have options. You have the option to preview it, preview the Gerber file, preview the 2D, preview 3D of your project, select the component based on the type and quality, and request for the code. They will contact you about the cost, or you can use the free assembly of 10 PCB option here. The link is below the video. You can click and place order. Now let's get started with the PCB. Come to PCBX.com, click here to register and complete the registration. I've already created an account, logged in. After that, click here, come to PCBX EDA, and then click on EDA. And here, click on this icon to create a new design. Your old designs will be on the list. Let's name it whatever name you like. I'm just putting it as recording. We'll enter our old product. I've already created a schematic here, but I'm gonna do adding the components one by one so you know how to add. For example, this NE555 IC. I'm coming here, click on this icon, and then you can see a lot of logic ICs interfaces by category or by search. NE555 and press enter. So this is NE555 DIP8. This is the dual inline pin or SOP from Texas Instrument. That's what I like. So you will see the symbol, you will see the footprint. If you want to have a look at it, click. And then you will see I'm holding my mouse going up and down to see the 3D. So this way we can enter. Now if I click again, it will create a new one. Click select and delete it. And let's say we want to connect this header connector. this looks something like this. A connector, something like that. So click, go to the connectors. Under the connectors, select the voltage, or the amount of current, or the pitch. You have so much options to select from. For example, 10 ampere. You will see all the connectors with 10 ampere capability. There are more options. I can select 50 per page. And this green icon, it shows that we have the all the symbol, footprint, and PCB, and the model. The next option would be number of rows, how many we want. We want number of position, we want two pins. Just wait for it. And this is the one. Click, and we have selected it. Now I'm clicking, press R. You see here, I can select here and see R means rotate right, E means rotate left. So just press R multiple times or whatever you like. So I'm pressing R, facing it this way. Now to connect a pin, we press on this button on the line, click and connect. If, for example, pin 5 up to here, click and come here, double click, it will get connected. To put a ground here, I just place it, and if you want to move it down, the line will be created for you. For our project, let's paste it, Control V, and press enter. The first result would be the same capacitor. Click and place it. Now, if you don't like this, you can move the model. Click on this, you will see a lot of options, and the model, you can hide it like that. Press R to rotate it. You can move it directly to that pin if you want. For example, let's add a resistor, 1 kilo ohm, resistor, SMD. I clicked on resistor, SMD, and here type 1 and space K, 1 kilo. Make sure to insert the space. And because we are working with SMD, surface mount device, select the size. All these are green, available with a footprint and 3D model. So I'm pressing R to rotate it. If you want to copy, I'm pressing right click to move. The middle wheel will zoom in, zoom out. Right click to move. Now I'm clicking, press Control C and then Control V. It will be copied. Again, Control V, it will be copied. And this is our whole design. Let me explain it. This is our connector. This is our 5 volts regulator, which receives, let's say, up to 18 volts, and it will output 5 volts for our timer. And then we have one push button, start. This is just a push button. It has 4 pins. And then I have another push button for stop. These are just resistors that we can connect a jumper using jumper wire to set them as parallel or in series to select the time. we have one LED which will be turned on, and this is our transistor that drives one relay for protection of this transistor. We have a diode, and again we have another transistor. This is BC817, which can handle up to 500 milliampere, and two relays are here. The pins for the relays are connected to this connector. Now, if you want to go to PCB, just press this button, update to PCB. If I click on PCB, we see all these components here. But if you don't, just click and update, so the component will be shown. Now if I click, that will disappear. Each component can be moved and replaced. Let's say I want to, if you delete any of these components, let's say this voltage regulator, delete it. Don't worry, come back to schematic, update to PCB, and update. The component has appeared. Now we are bringing it back. Now press V or via to create a via. That's a hole that we create. It goes from a PCB and creates a hole. This is my size here. If I click, this was like 194 millimeter. This should be 5 millimeter by 3 millimeter. From here we can switch the unit. The unit is shown at the bottom. You can see it's mil. I like to work with millimeter, and click. Now it's millimeter. And the grid that you see here, these grid are shown using dots if you want to work with those kind of dots, or if you want to work with line. And from here you can select the grid scale. And the other setting for the PCB is to click here and design constraints. Click here, come with a route. From here we can select the width of our wire. I'm not touching that for now, but in here it's 2.54 and 2.54. That's the maximum. And click save and exit. Now I'm gonna connect them here. For the power, we can connect it with a little thicker wire. Click and then click again. That is the route track. Blue is the bottom copper and then top copper. This is 2-layer. Again, we can select our layer. And this is 0.2. Because this is power, I'm going to create like 1.5. It says 1.27. That's the maximum. The reason for that is that the page has not been loaded. If I press reload, it will bring the latest values. Now let's go here, 1 point something. Even if I say 2, no, still let's check it. Design constraints, route, width. Oh, it's 1.2, so let's put it at 2 and 2. So now we can go 2 milli and I selected the wrong. I'm pressing V to go via, and then W for the wire, and select top. Like that. Ground is also this body. That's very close. I don't like it. Let's go this way. So that's a positive and negative. And this is a regulated 5 volts, the voltage. We have one capacitor. I'm pressing R. So this is not the wire on this side. Now let's add some text on the bottom layer on the silk screen. This yellow is on the silk screen. So let's hide this top layer, top silk screen. So let's add our text here. And then select it. Bottom silk screen, and let's make it 2 by 2, and then thickness make it 0.5, 0.3. So that is, if I make this even 4 by 4, and then 0.6. Now this text is huge. So this is the bottom, we are not worried. I can just put it here like this, it will be viewed. Once you are finished with your design, you can preview the 3D. If all the models are available, you will see it. Model for the relay was not available, so we will not be able to see it. So at this stage, you can place order by clicking on order PCB. If you want to place order PCB, on this screen, you will see your Gerber file, all the layers. You can turn them on and off and see. If you want to see or preview the 2D, here is the 2D, and if you want to see it in 3D, this is just a PCB. So from here you can select that quality of material, the type of material, number of layers, the board, and the color, finished surface, and all the other options. And the price would be $1. And I will ask for the shipping cost. Depending on the region, you will select maybe the cheapest shipping. You see PayPal, 7 point something. So you can get place order and finish. Of course, you need to log in, create an account, and verify your account. PCB Assembly or PCBA, click on order, select PCBA, As you can see, we can place also order for parts per PCBA. This is the same screen with a little difference here, that when you see everything, the same quality of material, type of material, all the options that you have, as you see, solder mask green or all these other colors. So after selecting all this, now you can preview the 3D on the screen and submit the code. Because I've already used my first order, you can use it with a 0, or depending on the type of component that you have, they will send you quotation. As you can see here, free assembly for your first 10 PCBs. So you can get that free. Don't forget that the link to purchase this is below this video in the description, so you can click and get the free PCB. And this is the PCB without any components. I printed it. I placed order using PCBX, and also I placed order for a fully assembled project, which looks amazing. This is done using a PCBX Service. Model for this PCB is RJT391. So this is 5 volts, 20 ampere, and I've connected these two relays in parallel, meaning here we have normally open. This normally open is connected to this pin, which means I put here a drawing, and then common. This common is connected to this common, and then NC, or normally closed, to the normally closed. So you can use all these pins to connect to your load. So how you connect is that your load will be connected to common. Even if you connect it to one of them, that would be enough. But if your load is 20 ampere, try to connect 2 wires, one common and the other common. And then if you want normally open, connect to this pin, the other wire. So normally it's open. When it's closed, it will connect these 2 pins for you. The same way in this side. On the board, this is our VCC. You can go for the voltage, you can go from 6 volts to 18 volts, because on the PCB we have incorporated a voltage regulator. When it gets up to 18 volts, it will produce 5 volts, and this is a timer. And then we can set our time from here, or we can solder resistors between these pins. The configuration could be either in series or in parallel. If you don't want to use this and you just want a simple resistor, you can just connect the 2 pins in here like this, and it will work fine. Now the AC power is connected from this area and onward. This is very hot area, so I have to be careful. And this is a start, and we are controlling the load. And if this runs, we can just press it to cancel it. You see, it stays on, but we can cancel it at any moment. So the cancel button also works perfectly. Let's measure this resistor. I'm using this K-Width auto select, so automatically it knows what I'm doing. For resistor, it detected 1.99, and I can press hold. As you can see, 1.996. This is 1.996 mega ohm. And placing it, replacing this resistor here. Now this is huge resistance, and let's turn it on. The load is on, and it will take a while before it can turn off, because we can do the math as well. 1.1 times R times C. So it will take a while. I cannot wait. Let me use this multimeter. Now if I connect my multimeter to the ground and measure the voltage here, you see the voltage. This voltage will charge the capacitor and it will reach a certain value that turns off the relay. You see, it turned off at that level. Now let's start it and let me show you. The voltage is too low and it's slowly increasing until it reaches, what was it, 3.5 or something, until it turns the light off, and here you can reset it. If you want the load to be on, and by pressing the start, turning it off, then we can remove this pin from the right side and move it to the left. Now it's connected to the normally closed. Now the load is on. When I press it, it will turn it off and wait until the time reaches. It will turn it on. I can cancel it at any time. Let me remove that resistor, put the small resistor so we can see quickly. So now, very small resistor. So now we change the operation in reverse. So you turn it off by the predetermined time and it will turn on after that. If this is a 5 volts, this can be input or output. If your power supply is 5 volts, you can connect it directly positive here, negative here, and all the circuit will be powered up. But if you're using external power, let's say 12 volts or 9 volts, whatever voltage you have, it will produce 5 volts, and this is a 5 volts output because you get higher voltage to the input, and this will be a regulated 5 volts from this regulator for other purpose that you need. This is a start and this is the reset. For a start, if you need external switch somewhere else, there is a 2 pin. Connect these 2 pins to your switch further away, maybe 1 meter, 5 meter, whatever you have. And also this is the reset. The same way there is 2 pin that is connected in parallel to this.